Our next speaker comes to us, from the Soil Health Partnerships of the National Corn Growers Association. Dr. Nick Gazer is our next speaker, and we're very pleased to have him with us. So, sorry, just 1 minute to set up the mic. Please welcome Nick Gazer.
Can I wander around a little bit, or? Thanks. And can I wander around a little bit if I'm?
Yes, please.
All right, cool. I just didn't know with the recording. Appreciate the opportunity to join you today. Talk a little bit about what we're doing with the Soil Health Partnership and what we've built over the last 3.5, almost 4 years now. And this program, it's an initiative of the National Corn Growers Association. It's farmer-led, farmer-driven, really throughout the entire program. And as you'll see as I go through the slides a little bit later, it is also kind of a consortium approach too. We have a diversity of partners that have supported the program. And so you could ask, what are we doing with the Soil Health Partnership? And what we're doing is we're enrolling individual farmers, representative farmers through across the Midwest, and I'll have a map up here in just a minute, to come in and set up replicated randomized strip trial designs on their individual farms. And within those strip trials, what we're doing is we're trying out new practices within their agricultural systems. We're incorporating practices like cover crops. We're maybe looking at reduced intensity tillage, moving from a full width conventional tillage to a strip till or no-till situation, or looking at more advanced nutrient management for nitrogen rate or timing trials. And within the context of this, we collect a lot of data. We're working with the individual farmers and the agronomists focused on their user experience and giving them a positive user experience in the program first, so that they're going to continue to participate year over year for at least a 5-year duration within the same field, so we can look at a little bit longer term trends and any changes. In the data we're collecting in the program, we'll have a few summaries a little bit later on in the presentation, but we start out with some baseline soil sampling. We conduct a routine analysis sampling on 1 acre grids, looking at stratified sampling, 0 to 2 inch cores, 2 to 6 inch cores, and then we couple that with doing composite samples across each replicate strip to assess, to pull the sample, do a subsample, send half of it to Cornell's lab to do their assessment, and then also we do the Haney test on that same basis as well. But we don't stop there. We want to understand and help to characterize the soils at this production scale, this real working farm level, but we wanted to move beyond the soils as well and look at the impacts of crop growth, crop health. So we take aerial imagery in every field, and we follow that up with georeferenced yield monitor data to get the assessment of crop yield, so we can start pairing the georeferenced soil sample information with the georeferenced aerial imagery information, with the georeferenced yield data that are coming from the field. And then at the end of the year, we collect all the management practice and crop input information for that individual field as well on the strip by strip basis. So we can start put together these pieces to understand the interactions, and ultimately our membership base within the National Corn Growers want to understand these interactions as well between our measurable soil health indicators, our environmental responses, so water quality, air quality, biodiversity, our economic responses as well, and as well as just the production, the yield resiliency story as well. So we're trying to gather the data to link these pieces together in a more comprehensive story at scale. This is a translational research scale. So we're trying to figure out what holds up from maybe the small plot research that we could take to our farmer level on a broader scale basis. And so what have we done over the last 3.5, 4 years? We've built this network. We originally enrolled 20 farms per year over the first 3 years, and then we added a few more. So in total, what we have across this network today, with 6 sites right here in Missouri, is a network of 111 farms. 111 farms trying out in which these trials are set up in place in a very standardized way. So we can look at an individual farm. An individual farm is set up as maybe an individual publishable unit with a randomized complete block design, and then we can follow that over time. And then we follow that, again, in a standardized approach, using the same protocols across each individual field. It gets messy when you look at individual management practice information and things like that. That differs, but at least the systems comparison holds up across the farms, so we can look at the scalable approaches. And what's our impact as we've enrolled these farms? What have we brought into the network? Well, first, if we add up all the individual fields at scale across these programs, we ask an individual farmer to enroll a 20 to 80 acre field. So on average, we have about 40 acres per farm that have been enrolled in the network. So we have about 4,000 acres in testing across this 12-state network, mostly in the upper Midwest. And along with that, we have a whole bunch of field events. We're gathering a lot of data, but we also want to communicate and partner with those locally to talk about what's working, what's not working, what are those operational management strategies that we can use in the local, that are site-specific within that soil type, within that cropping system, those climatic gradients that we have site to site. We want to have those conversations. Oftentimes they're very candid conversations, because what works here in Missouri isn't necessarily going to work the same way in central Indiana or Wisconsin or Minnesota. But so we want to have those conversations very locally, and that's where these events really come in. And if we add up all the attendees, these 60 events were from last year, 2017 alone. And if we add up all the attendees, all the farmers, all the agronomists coming into the events, and we add up the acres that they're either farming or they're consulting across with the people coming into the program, we estimate a reach of about 30 to 40 million acres in the program touched in this 1 year alone. And so we're starting to, again, think about how do we scale the impact of the conservation programming as we move forward. And so we can have the individual events. We can talk individually to individual farmers, have the small scale events, but we're trying to also think about what are other ways to get information out there. How do we reach broader acreages? How do we reach broader sets of farmers in different areas? And this is where our media campaign comes in. And I saw Jenna come in, and Jenna Higgins-Rose is our communication lead for the program on contract to us. And she's really developed a strategy to start working with ag media, with non-ag media, to get the information out there in a more consistent fashion. And so what we've seen in 2017 alone is we saw growth. We had about 415 stories covering the Soil Health Partnership and the individual farmers in the program. Very positive stories of voluntary approaches our farmers are taking to try to understand the interactions across these multiple system components, agricultural system components. And these stories are pretty interesting. We're seeing almost a story per day come out on average covering the Soil Health Partnership. But it's this engagement as well, these earned media impressions, these engagements with the stories, people clicking on links, spending time reading the stories, where we can see, again, the scalability to the program, extending that reach beyond what an individual conversation might have. So at 387 million earned media impressions, Jenna can tell you more about what that actually means after the fact. I'm just a soil scientist. I'm not a communications expert up here. But it's a big number. It's a big number of people looking and engaging with the stories over time. And this is the second year in a row we're hovering right around 400 million earned media impressions, indicating that there is interest in the stories both within ag media, but also outside of ag media, again, as well. As we continue on, we're trying not to do this alone. The strength of the partnership lies in that last word, the partnership, the collaboration we have with many different organizations we're collaborating with. And the organizations represented on this screen represent only the organizations that we have a tangible collaboration with. We talk with many, we engage with many other organizations beyond this, but these are the companies, the universities, the grower organizations, and others that we can actually point to something and say, yes, we did, maybe we had a joint news release, or we had a shared plot where we set up a field plot together, or we had a shared field day. So one form or another, sharing information, tangible information, collaborations across these organizations. And again, where the benefit lies is that we're hoping that we can work together to relay more consistent information on the linkages of these many agricultural system components that we're studying together collectively across these organizations. And where it becomes interesting, though, and you'll see this on the next slide as well, we have some groupings up here amongst organizations. We have grower organizations getting engaged, traditional grower organizations. Our university organization, our universities are heavily engaged, maybe no surprise here. We're also working with agencies at the federal and state level, but then we also have conservation organizations partnering along with us as well. And an ag industry here too. So it becomes pretty diverse, and we don't always get along in the same and have the same thought processes on the same topics. But what gets me really excited is you have multiple people, multiple sectors coming together to talk about what's working and what's not working and sharing the best approaches. And I'll carry that forward with our steering committee as well. If I can get it, there we go. Our steering committee and the supporters to the program, you see that similar kind of diversity. So as we look to the steering committee, we have, again, the corn growers, we have the wheat growers to look at wheat rotations and expanded geographies. But then we have ag industry and the ag supply chain. So we have Monsanto coming to the table. And we have the Midwest Row Crop Collaborative, which is a group of organizations that span the ag supply chain from an input provider side all the way to a General Mills or a Kellogg's or a Walmart even. They're part of the Midwest Row Crop Collaborative. And what's interesting, so maybe these organizations you might expect to be part of this program, but they're partnering, and they're on our steering committee too, partnering with the environmental or conservation organizations. And again, this is where we gain power. We're trying to find that common ground, to find strategies to work together for the common good of agricultural production and yield and economic resiliency along with environmental resiliency over time. And we have tremendous financial support from additional organizations represented on the right. So now I'm going to go into a couple of the summaries and show you a little bit more on what we've built over the last 3.5 years in terms of sites, and then maybe go and provide an example of how we're starting to summarize the information coming out of this network that we've built. So year over year, what we have up here is it's representing the site growth by individual states and what our trajectory was as well. So between 2014 and 2017, we had tremendous growth, individual farmers raising their hands, perceiving value in the program and wanting to engage. Again, representative farmers coming into the program. And if you look on the right, what you can see is a yellow or orange line representing what we thought would be the interest. That was our original trajectory for the program. And that was 20 farms per year over a 5-year period of time. In addition to that, we can see a blue line. It's this line over here. And this blue line that we track is the actual growth of the program. So initially in 2014 and in 2015, we had to get the program started. We ran into a few growing pains, if you will, in those early years. But then we hit an inflection point. We started working more with our farmers, and they started to see more about what the program was all about. And we saw the interest really kind of take off. Along with some funding support we had to enable the growth, we saw more of our farmers saying, yes, this could be a pretty good program. I could learn from this. I want to engage. I want to figure out how this works together. So we had the growth much greater than we expected. So we hit our growth goals of 100 farms over 5 years. We actually hit those goals 2 years early as we enrolled farmers in 2017. So who are these farmers coming into the program? I mentioned they're representative, so I'll have 2 slides up here to kind of show you who they are, who these farmers are in the program. As a first way to represent that, you saw the map earlier of where the farms are, so maybe as no surprise to anyone up here, if we look at the rotations, 75% of our farmers in those areas enrolled in the program are corn and soybean farmers. And if we look at the USDA maps for corn production and soybean production over those same acreages, yeah, that makes sense. Again, we want to bring in the farmers who are just like their neighbors and maybe new to the practices so that we can focus on those transitions and come out with better information on transitions of practices in current agricultural climates, current markets, current technology, so we can spread that information. Another way to look at that would be to look at the tillage represented across the farmers in the program. So if I add up and look across all the farmers and the management practices for tillage, that would be represented here on the right. And you can see about 37% of our farmers are continuous no-till farmers in the program. In addition to that, we have conventional tillage, we have maybe a vertical till tool use across 33%, and we have rotational no-till about 10% as well. And so I compare that to where we're at with this is ARM survey data coming out of the USDA on the left. And we have this Heartland survey, so it's survey data. So we're going to use it as a basis, a starting point to assess how representative we might be. And we have about 33% of our farmers in that survey are no-till or strip-till. So it's not a one-to-one matchup, but it's relatively close in terms of trying to bring in farmers who are representative of their geographies to get, again, a realistic perspective of where our soils are at, what management practices we're using, and how we might develop those operational management strategies to help the vast majority of our farmers progress to reach those environmental, the production, and the economic outcomes site to site. So what have we gathered in terms of data? What have we grown over the years? Really, if we focus here on the bottom, we've gathered about 260 site years of crop input and management information across these farms. We compile that with the georeferenced soil sample data. We have a soil sample database of over almost 17,500 soil sample points, and this spans across the routine analyses, the soil health assessment samples that we've come in, and this is all, again, off real-world production scale farms at a minimum of maybe 40 acres apiece, or an average of 40 acres apiece. We couple that with the aerial imagery and the strip level yield points. We have about 2,000 yield points that we've captured in the program as well. And this number right here, the 1,900, almost 2,000 yield points, would represent an average of all these points across an individual strip here. So if we really take that out, as we're looking at this data set, this 2,000 yield points or strip averages is really about 3 to 4 million individual yield points, all with a GPS point attached to them. Okay, so what? We have a data set we're building up. What are we actually getting out of this? Well, as we're looking to early results, we have a lot of data. We have a lot of ways we can start to piece the data and start to analyze it. And I'll just go through one example, recognizing we're going through many different other scenarios and trying to work with others. Kristen has been part of this team as well that's helping us to analyze the data as we're going ahead. So first, we're starting to just look at the individual soil parameters. So we have the routine analysis coupled with the Haney test, with the cache assessment. And this is just one example. We'll follow aggregate stability through how we're starting to piece the information together. So we have aggregate stability as analyzed by the Cornell lab, and we're starting to just break it apart by our soil texture classes as a way to look across and see what holds up from our small plot scale to maybe our real world production scale farms. Do the trends hold up? Do our common assumptions about the interactions amongst crop management, our individual soil parameters, our environmental parameters, do they hold up at production scale across vast landscapes? Well, yeah, certainly some of them do. And where I'm hopeful that this information might be useful is for an individual farmer to take a sample, get their aggregate stability score, and help to come up with and start to see where they might fall in and amongst other farmers within that same soil texture class. So if I'm I have a silt loam soil type, and I come back with a score of maybe 10% with my aggregate stability scoring, I can see, hey, maybe there's some opportunity for growth there. But then it comes back to the so what? Why should I care about this? Aggregate stability is interesting. I learned in soil science this is a good parameter I should be interested in. But how does this turn into something that's going to impact my yield, my economics? Can I take this to the bank? Can I take this to the bank to stabilize or de-risk the loans I might take out from my farm? How does it interact in those ways too? So we're starting to take it to the next level. We have that same aggregate stability scoring. As another way to look at the soil texture class, I just took percent sand as a continuous variable we have up here. So we can track that, 0 to 100%. And then we can look at corn yield. So this would be, these little blue dots are actual raw data points coming out of the individual farms in the program. We have about 450, the sample size is 458 up here. And if we're looking across the individual raw data points, I just tried to fit a linear multiple regression equation in there and realized very quickly we're not explaining a lot of the variability with a linear equation. As Kristen mentioned before this, it's largely nonlinear. But for an individual farmer, I can look at where the raw data points land at individual soil texture class or individual percent sand measurements. So if I have 20% sand in my soil, I can look at the range of values here as well from aggregate stability, so I can see where I land there. And then I can look at the opportunity for where it lands with yield. So what I can see in this variability from one end of this curve to the other, or just the individual raw data points if we don't trust the model yet, we can see maybe 10 to 20% yield, associated yield difference with those aggregate stability scores pulled off of representative production scale farms. So when I'm talking to my individual farmers within my membership base for the National Corn Growers Association, this draws some attention. 10 to 20% yield associated yield difference is a big yield difference change. This is saying, hey, maybe this is important enough to me that I should pay attention to this and try to figure out what I can do about this. So we can take it to the next level. So this is a good starting point. But what can I do about it? What can I change? So let's talk through one example of aggregate stability and management practice interactions. And this one, again, coming out of soil science, you might see this as something, no surprise here. Well, actually, here we go. No surprise here. We have conventional tillage compared to reduced tillage scenarios, aggregate stability on the left side, and we can start to see some groupings. So we have conventional tillage. If I look at the mean and two standard errors above and below that mean, we have some groupings. Conventional tillage year over year is grouping a little bit lower, traditionally lower than the reduced intensity tillage. So this is within a silty clay loam soil. Does this hold up over other soil types? And we can start to look at that. So if I look at the other soil types, now I'm going to go to a silt loam soil, and we're starting to challenge ourselves here and ask, do these relationships hold up? So now we have these same tillage categories: conventional tillage, no-till, reduced till, strip till, aggregate stability, a little bit bigger sample size, and we're starting to see maybe there's something else going on here that's driving this. This doesn't necessarily match up with what we learned in soil science exactly. So we're trying to understand, this is an early cut of the data, why isn't the tillage that we hear so much about, why isn't it driving a change, or why aren't we seeing an associated change in our aggregate stability scoring? This is maybe a little bit different than what we traditionally hear, and that's what we're trying to understand. As we're looking from the small plot scale to the translational scale, what holds up, what might not hold up. And we can hypothesize as to what that might mean too. So that's all well and good for a farmer, but it's also continuing to go on and say what holds, how can I take this to the bank again? And I'll jump to this one just in the nature of time. And we can start to look year over year with the individual farms in the program. So every farm, every single one of those dots on the map, every single one of those farmers gets an economic report card coming back to look at their economic performance year over year in the program. And so we have the acres in the control up top. This is a 2017 example. So all these individual strips have their own economic performance within the strip assessed. And then we can see the acres with the cover crop on bottom. So we can start to look at performance here. We have about 22 acres in the control, about 28 acres in the cover crop. This is just one example of how we can track things. And we can see it in this example, our profit is negative $46 an acre for the control, so we're definitely losing money. And then in the cover crop acres, we're maybe losing $140 an acre. So losing a ton of money here based on this initial assessment. And our yield story here is about 208 bushels per acre in the control without cover crops. And we have about 180 bushels per acre with the cover crops. So this initially doesn't look like a very positive story. And we can track that change over time with on the right-hand side with the differences between the controls and the cover crop strips. So again, initially it doesn't look very positive. But as we go into this, as we look at this scenario, we need to get hands-on with it, just like you would expect with any individual farmer and agronomist working in this scenario. So down here in the cover crop strips, we can see a really, really red strip. This is the performance across yield, but this red strip, we had an edge effect there, an edge effect that disproportionately affected the crop yield in that one strip. So this wasn't associated with the cover crop. This strip happened to randomly be placed next to the edge of the field where we had this effect that drove down the yield. And if we're not working individually with this farmer, an agronomist pair to understand that, this story could look pretty negative, or it does look really negative. So if we look at the fair comparison and maybe factor out that strip, the scenario changes. The scenario changes quite a bit. So this is the same field, just with that one treatment or that one strip that was disproportionately affected by that edge, the border effect there, taken out. Now we can look at the yield story, and the yields between the control and the cover crop, we start to look pretty positive. And if we look at those associated differences year over year between the control and the cover crop, we can start to see in 2017 we have a positive response again with the cover crop treatment. And this is the information we're trying to put in more farmers' hands, more agronomists' hands at scale. We know there are massive environmental concerns that we're trying to address in agriculture today, along with economic concerns keeping our farmers in business year over year, along with the production demands that Kristen talked about as well with global production. So we're trying to get this out and put this in more farmers' hands so that they can understand what the opportunities look like going forward. So we're also looking at the environmental piece. And this is another component we're trying to put in our farmers' hands. We hear a lot about erosion, and we're trying to bring the environmental models into it and put them in useful tool formats for our farmers to understand how this factors in as well. So within this, we're looking at erosion, and I'll just jump to the next one. We're also looking at greenhouse gas emission scores across the Midwest. We partnered in a carbon insetting framework project with a number of organizations, and these maps, we're going to have some publicly available tools that you can look at management practice impacts on greenhouse gas emissions, and this is based on 250 million model runs that we did within the program across these states in the upper Midwest. So we'll have those coming out as well. And then we're looking more to link in with and integrate this information into better grower tools, better agronomist tools, based on positive user experiences, and a real focus on the positive user experiences to really engage more of our membership base and other members across other commodity organizations as well. So I'll wrap up here. I know I'm out of time, but I really appreciate the opportunity to join you today and talk a little bit about how we're trying to look at the scalable approaches to engage more of our farmers.
Thank you, Nick. We can take just a few questions. We have a few minutes. If there are any questions, there's one back there.
Thank you. Thank you for your presentation. It's an impressive program, to say the least. I'm curious, we've heard from other speakers today about this sort of gold standard of perennials and organic systems for soil health. I'm curious if any of the farmers that you're working with are organic, or if they're doing any agroforestry practices, alley cropping, windbreaks, riparian buffers, if you're seeing perennials in those farm systems.
So our goal in the program is to enroll representative farmers, and organic acreage today is a couple percentage points. We know it's growing very rapidly, but within the program up to this point we haven't. We do have room for maybe one or two organic farmers out of this network of 100, 110. But again, the effort to the program is to be representative and understand where our production acres are actually at today.
Okay, I think that's it. So thank you to Dr. Nick Gazer for that excellent presentation.